Hello guys, welcome back to the Swift Academy. Today we are trying to solve another LeetCode problem. It's called valid anagram. What is the valid anagram? When you are trying to solve this problem, you have to look at two strings that already given to you. For example, here we have one string called S and another one called T. And if they are a valid anagram, for example, if the T is a valid anagram of S, it means that every character that inside the S string already has inside the T string. What am I saying is that, for example, in the S, we have 3A, we have 1N, we have 1G, and 1R, and 1M. But this is on the S. How about in the T string? Or the same is, so let's count it. A, yep, that's 3. And N, yes, we just have one N. About G, yes, we just have one G. About R, yes, we have one R. And about M, yeah. Okay, you can see that we have all the letters that already has inside the S, it is inside the T. And the T, the count of the characters is equal to the S. This is a valid anagram for us. If we are going to take a look at the next example, we have the S, we have the T. The count, both of them is equal 3. But how about the alphabets or the characters on each string? We have one R, we have one A, but here we have T and here we have C. So the count is equal, but not all the characters in both together is not the same. So that's not a valid anagram. Now we are knowing how we can determine if the two string is anagram or not, we can solve this problem. One of the best way to solve this problem by using the hash maps, because we can occupy the dictionary with each letter and count it. There is other ways to solve it. I'm going to show it later, but let's focus on the hash maps now. So the hash maps consist of the key and values. So we know that all of them has a key and value. We can put all the S and T inside the hash maps and count all the letters and the value or the count inside each hash maps. For example, if this is the hash maps of the S and if this is the hash maps of the T, we can just do the same thing that we did about putting all the characters there and just putting the count or and how many characters inside each of them. So we have the A, N, G, R, M, and then the same thing for the T as well, and then comparing these two hash maps together by iterating through one of them and trying to find out the next value if inside the other hash maps as well. This is one way that we can do it inside our programming languages, but I'm trying to solve it in another way too. For example, how about that? If first of all we are going to check if the count is equal or not, so the count should be equal. If the count of the characters is equal, then we can simply doing one more thing. We can do the sorted. If we sort both a string and then put them together, the sorted version, if they are equal, it means that this is an anagram. Because, for example, if we sort the S, then we are going to have A, then we are going to have the G, M, N, R, and then it will be equal to the T or not. So up to now, we find out we can solve this problem either in the sorted way, that we can use the self-sorted frameworks inside each programming languages, or we can using the hash maps. But which one is better? The sorted algorithm, the best sorted algorithm in the world now, it's just like the n log n. This is the time complexity of the best one right now. The time complexity of accessing data inside the hash maps is O1. So when we are trying to accessing something inside the hash map, it's going to be O1, and because we are going to iterating through all the characters inside each string, then we have to go through all the characters, so it will be On. So just imagine that now we have the n log n and we have just On. So the hash maps is gonna be better, and the sorted one is another approach we can do it and solve this problem. This is not anything wrong about it. During your interview, you have to talk about these kind of opportunities that you have to solve this problem, because then the interviewer understand that you find another solution for that problem, and calculate the best approach to solving. This is how you think, and you have to think loud and talk loud about your solution, about your approaches for your interview. So let's jump into the code. So now with all the description that we have, we are trying to solve this problem in action. As you can see, this Leet Code provides us a class solution, and inside that class we have a function. The name is Anagram, and the input of that function is one S and one T, and expecting to returning a Boolean value if it is an anagram or not. The first thing that we have to check if it is both of the strings has the same length or not, the count of both of them are the same. So we can simply just checking the count at the beginning for the best edge cases. If we check that, then we are not actually going to through all the codes behind it and trying to find that, oh, this is not an anagram, so returning false. So at the beginning, the best thing is that to check this edge case. Now we want to solve this problem with your dictionary or hash map. So I'm just pasting the codes and going through it line by line. We need a dictionary as a S counts, for example, and another one as a T counts to hold the characters and the total number of each characters inside each string. So I'm creating a dictionary like character integer here and the character integer here too, and then iterating through each string and occupying our characters here. For example, we have the S counts. If the characters exist or not, you are going to be familiar with it. This is not just trying to find out if the dictionary already has that character or not, because if it doesn't have, it will be returning nil, and we don't want to have nil and crash in our application. So with this double question mark, we are solve this issue, and if it was nil, it isn't exist, so we're returning 0, then we are counting it. So it means that we are just adding each character to our dictionaries and count them. By these two loops here, we occupying our dictionaries, and then simply we just iterating to one of our dictionaries like S counts and trying to see that if the value inside the other dictionary is equal to that one or not. What am I saying is that, for example, when we reaching to the A, we take it out from the T counts. If it is already exists in our dictionary, the A or not, then we are comparing the value. It means that the count of the A to it. If it is equal, we are continuing our loop. If it is not, it means that no, this is not an anagram. If we going out of this loop without any issue, it means that okay, these two strings are both anagram and just returning true. So this is just the naive way of using the dictionaries with a lot of code to check if it is an anagram or not. But I'm trying to show you one better approach that Swift provided for us. I just paste some codes here. This is trying to solve the problem by the high order functions that Swift provided to us. Look at here. It is just have 3 lines of the codes. This is the dictionary high order function that takes the string and then trying to do whatever you want, whatever the condition you provided here inside the by object. For example, you can actually do any change you want here, and telling the dictionary to group the string for me in that way. This is so good. You can solve so many problems in your programming, in your applications with this line of the code. And I highly recommend you to check these high order functions inside the Apple or Swift documents to get familiar with that. As you can see, it is so easy and you can solve this problem. But before you use this approach, you have to go through it inside your interview. Your interviewer should already know that you understand completely how it is going to work, how you are going to approaching and putting the objects or characters inside the dictionary, and then how you are going to check that. So please do that first, and then talk with your interviewer that you have the better approach because of the Swift language and you can do it very easily. So this is other way of solving this problem with the dictionaries or hash maps. So now, how about the sorted approach? We talk about it. It means that simply we can just returning if the s dot sorted is equal to the t dot sorted or not. It is going to sort the s, going to sort the t as well, and then comparing together. And if both of them are the same, it's going to be anagram. So this is one other way to solve this problem. But as we talk about it, this is just about the time complexity. The time complexity of the sorting is a little bit higher than using the dictionaries. So you can actually approach this way. There isn't anything wrong about it, but your interviewer should know that, okay, you find another way, but you be aware of the time complexity of each approach. So now let's submit it to see what is happening. Now we are trying to submit by the sorted and then going for the dictionaries. So by submitting by the sorted, let's see how we are getting the data. Okay, it means that 32% of the others. And now let me commit this line of the code and get back to the dictionary way and then submit the application as well. See how it will be responded when you are using the dictionaries. You can see that it is so much faster and better way. So always trying to use the dictionaries because of the time complexity. If you can see that in the runtime section, the total runtime for the dictionary is 24 milliseconds, but for the sorted it's 40 milliseconds. I wish you the best in your interviews, and please subscribe to this channel. And if you have better approach to this question, please put some comments down there and like this video. See you soon.